Good day, learners! Are you ready to have fun with math? How do you feel today? I hope you are all okay. I am your teacher Anne, and let's make learning more fun. Before we start, here are some reminders to keep in mind. Number 1, stay alert and focus to the video lesson. Number 2, prepare your pen and paper for your answer sheets. Number 3, sit back and relax as you enjoy our learning for today.
Good day, learners! We are now on Quarter 3, Week 3, and our lesson is all about the theorems on trapezoids and kites. In this lesson, you are expected to prove theorems on trapezoids and kites. My dear learners, I want you to get your math materials, ruler, protractor, pencil, ballpen, and notebook. I hope you are ready to listen as you walk through with me in the world of trapezoids and kites. I am also requesting your 100% attention as we navigate today's lesson. Well, for the past 2 weeks, you have faced the challenge to learn and put into your heart the different conditions of a parallelogram and investigated the properties to find measures of angles, sides, and other quantities involving it. You were also able to prove the theorems on the different kinds of parallelogram such as a rectangle, a rhombus, a square, and ended up moving with proving the midline theorem. For today, we will be focusing on the discussion on proving theorems on trapezoids and eventually apply them. Let us define some terms. As we recall, trapezoid is a quadrilateral in which one and only one pair of opposite sides are parallel. The parallel sides of a trapezoid are called bases. The non-parallel sides are called legs. The pair of angles formed by a base and the legs are called base angles. I want you to draw a trapezoid ABCD. So you have a 4-sided polygon with one pair of parallel sides. Again, name it trapezoid as ABCD. Well done! Great job! A trapezoid has 2 pairs of base angles. I hope you can identify them. The base angles on trapezoid ABCD are angles A and B. The other base angles are angles C and D. Remember that the bases are the parallel side. The legs are the non-parallel sides. While the base angles of a trapezoid are 2 consecutive angles whose common side is the base. I hope you were able to name the parts of the trapezoid. I repeat the terms you need to remember on trapezoids. The bases are the parallel sides, the legs are the non-parallel sides, while the base angles of a trapezoid are the 2 consecutive angles whose common side is the base. Now, when do we have an isosceles trapezoid? If the legs of the trapezoid are congruent, then the trapezoid is called an isosceles trapezoid. The legs of the given trapezoid ABCD are segment AD and segment BC, because they are the non-parallel sides. As the mark tells, AD or segment AD has the same measure as segment BC. This means that segment AD is congruent to segment BC. Therefore, that is an example of an isosceles trapezoid. Got it? Very good. I hope you're still with me. Now, we are ready to face the challenge to know the theorems of a trapezoid. Come on, let us travel to the world of trapezoids. Let us look to the first theorem of an isosceles trapezoid. The first theorem states that if a quadrilateral is an isosceles trapezoid, then its base angles are congruent. So, if you draw trapezoid ABCD, meaning you have a quadrilateral where segment BC is parallel to segment AD, which are the bases, and the non-parallel sides, which are the legs, are segment BA and segment CD, wherein segment BA is equal to segment CD. With that consideration, we are concluding that angle B is congruent with angle C, and that angle D is congruent to angle A. Now, let's see that vividly. Let us have an illustrative example again. I want you to draw an isosceles trapezoid and mark one of the upper base angles equal to 120 degrees. And let us together find the measure of the other angles. Are you ready? Did you get it? I will repeat. I want you to draw an isosceles trapezoid and mark one of the upper base angles equal to 120 degrees. And let us together find the measure of the other angles. Do we have the same figure? Very good. Let us solve that now. Since we know that one of the upper base angles is equal to 120 degrees, therefore the other upper base angle will be equal to 120 degrees too. Why? It is because it is stated on the theorem that base angles of an isosceles trapezoid are congruent. Now, how do we find then the measure of the lower base angles? Well, one of the lower base angles will be equal to 60 degrees. If you got that, well done. Very good. For those who are confused why, the only reason for that is the measure of angle u sub 1 and angle x are said to be supplementary. Meaning, when we add angle u sub 1 and angle x, the sum is 180 degrees. Did you get that? I just said that angle u sub 1 and angle x are supplementary. Therefore, the sum of their measure is 180 degrees. By transposition, we will have x is equal to 180 degrees minus u sub 1. Since angle u sub 1 is 120 degrees, subtracting that from 180 degrees, you will get 60 degrees. That will be the measure of angle x. Now, since angle x and angle y are base angles, and base angles are equal, therefore, angle y is equal to 60 degrees. I hope you were able to keep up. Good job! Wow, we are done with the one theorem of isosceles trapezoid. Let us move on to the second trapezoid or the second theorem of an isosceles trapezoid. It states that if a quadrilateral is an isosceles trapezoid, then the diagonals are congruent. Draw isosceles trapezoid ABCD, then I want you to draw the diagonals of trapezoid ABCD. Do you remember what diagonals are? Well, a diagonal is a line segment joining two non-consecutive vertices. Were you able to do that? You should have line segment AC and line segment BD inside the trapezoid. Do we have the same figure? Good job. We can only see that trapezoid ABCD is an isosceles if and only if segment AC is congruent with segment BD. Let us have an illustrative example. Using isosceles trapezoid ABDC, if segment AD is equal to 25, let us find the length of segment BC. How do we solve that? Well, since segment AD is equal to the segment BC, then the measure of segment BC is equal to 25. Why? Simply because diagonals of a isosceles trapezoid are congruent or equal. Wow! And we are almost done on proving the theorems of trapezoid. Let us move on to the third theorem of an isosceles trapezoid. It states that if a quadrilateral is an isosceles trapezoid, then the opposite angles are supplementary. So we have trapezoid ADCB. Getting the sum of the opposite angles, which are the measure of angle A plus the measure of angle C, is equal to 180 degrees. Same is true as we get the measure of angle B plus the measure of angle D, and that is equal to 180 degrees as well. Let us have an illustrative example of that theorem. In the given isosceles trapezoid, one of the angles is equal to 72 degrees. We are asked to look for the measure of its opposite angle. Since the two angles are opposite with each other, then their sum is equal to 180 degrees. By substitution, we will have 180 degrees is equal to 72 degrees plus x. By transposition, angle x now is equal to the difference of 180 degrees and 72 degrees. The result then is that angle x is equal to 108 degrees. Did you get the same answer? Very good. Always remember the theorems of trapezoid. Number 1, if a quadrilateral is an isosceles trapezoid, then its base angles are congruent. Number 2, if a quadrilateral is an isosceles trapezoid, then the diagonals are congruent. And number 3, if a quadrilateral is an isosceles trapezoid, then the opposite angles are supplementary. Let us now proceed to kites. Kite is a quadrilateral whose four sides are drawn such that there are two distinct sets of adjacent congruent sides. Meaning, a kite is a quadrilateral in which exactly one diagonal is the perpendicular bisector of the other diagonal. It has also two pairs of consecutive congruent sides, but opposite sides are not congruent. In kite ABCD, segment AB is congruent to segment CB. Same is true with segment AD is congruent to segment CD. Got that? Very good. I hope you're still with me. Now, we are ready to face the challenge to know the theorems of a kite. Come on, let us travel to the world of kites. Let us look to the first theorem of a kite. The first theorem states that if a quadrilateral is a kite, then it has one diagonal that bisects the other diagonal. Draw kite ADCB. Then, I want you to draw the diagonals of kite ADCB. Just like what we've discussed a while back, a diagonal is a line segment joining two non-consecutive vertices. Were you able to do it? You should have line segment AC and line segment BD inside the kite. Do we have the same figure? Wow, great! We can only say that quadrilateral ADCB is a kite if and only if one of the diagonals bisects the other diagonal. As we can see in the figure, segment AC bisects segment BD. Therefore, segment BM is congruent to segment DM. Let us have an illustrative example. Using kite APDC, if segment CE is equal to 4 cm, let us find the length of segment AC. How do we solve that? Well, since segment CE is equal to segment AE, then the measure of segment AE is equal to 4 cm. Why? Simply because one of the diagonals of a kite bisects the other diagonal. Therefore, segment AE and CE are congruent or equal. So, to get the length of segment AC, we will just add the length of segment AE and segment CE. By substitution, we will have segment AC is equal to 4 cm plus 4 cm. Then, perform the operation, we will get 8 cm. Therefore, that is the length of segment AC. I hope you were able to keep up. Good job! Let us move on to the second theorem of a kite. It states that if a quadrilateral is a kite, then it has one diagonal that bisects a pair of opposite angles. So we have kite BCDA, and segment CA bisects angle C and angle A. By bisecting angle C, angle BCA and angle DCA formed, while bisecting angle A, angle BAC and angle DAC formed. Therefore, angle BCA is congruent to angle DCA. Same with angle BAC is congruent to angle DAC, since segment CA bisects the two angles. Let us have an illustrative example of the theorem. In kite EFGH, segment FH bisects angle F and angle H. Angle H measures 44 degrees. We are asked to look for the measure of angle EHF and angle GHF. Since segment FH bisects angle H, the measure of the two angles formed are congruent. Therefore, angle EHF and angle GHF are congruent. We will have angle EHG is equal to the sum of angle EHF plus angle GHF. By substitution, we will have 44 degrees, which is the value of angle EHG, is equal to x plus x, since the value of EHF and angle GHF are unknown. Then, perform the operation, we will get 44 degrees is equal to 2x. To find the value of x, we will divide both sides by 2. The result then is that angle EHF and angle GHF is equal to 22 degrees. Did you get the same answer? Very good. Let us move on to the third theorem of a kite. It states that if a quadrilateral is a kite, then its area is half the product of the lengths of its diagonals. So if you draw kite BCBA, the diagonals are segment CA and segment BD. And to get the area of a kite, multiply the lengths of the diagonals and divide it by 2. Now, let's see that vividly. Let us have an illustrative example. Are you ready? To get the area of kite JMLK, get the length of the diagonals first. The diagonals are segment MK and segment JL. The measure of segment MK is 8 plus 15, or that is 23. On the other hand, the measure of segment JL, or the other 8 diagonal, is 20 because segment MK bisects segment JL. So, 10 plus 10 is 20. Then, we will use the formula 1/2 multiplied by the length of the first diagonal multiplied by the length of the second diagonal. By substitution, we will have 1/2 multiplied by 23 multiplied by 20. By performing the operation, we will get 230 squared units, which is the area of the kite. Did you get it? Good job! Wow, we were done with the theorems of kite. Time rhymes so fast, and we did it. We were able to investigate the theorems on trapezoids and kites. Wow, that was great. You did very well. Just go back on the theorems and master them with the help of the examples given to you. Well, that is all for now. Again, I want you to review what we have learned today. Go back and practice correctly. Enjoy every mathematical experience. Stay healthy and stay safe. God bless.